in, but I'm gonna get started. So do this really quickly. I'm Jacob. I'm a coach here at Leland, and I've worked lots of different places, and I tutor kind of on top of all of that. I am a 99th percent score on the GRE, and this should help for both the GRE and GMAT. Okay, so we're going to be covering a lot of math tips and tricks you can use on these exams to help you save time and earn those points. We're going to start with percent change and understanding some intuitive math with percent changes and using a new formula there. Then I'm going to be going into what I call these rapid fire arithmetic shortcuts. There's about 6 different shortcuts you can use to help you avoid doing the calculator and get to accurate results really quickly on these exams. We'll talk about how to use the difference of squares trick as well to simplify some problems. We'll talk about quadratics, and then we can part with some advice and see if you have any questions. And anyone just feel free to unmute and ask something if you want me to stop and explain it more. So let's start with percent change, because I think this is a good example of how these exams try to use your intuition to trick you. So let's walk through the logic of this first. Let's say you have $1,000 invested today. And in 1 year, the investment grows by 10%. The next year, the same investment shrinks by 10%. What is the value after the second year? So a lot of people will say $1,000. You had $1,000, it went up by 10%, went down by 10%. So it ended up back at 1,000. That's actually wrong. The correct answer is $990. So one takeaway from this is actually percent decreases always hurt more than percent increases help. And this is the type of trap you might see on, say, a GRE quant comparison where you're comparing two values and they expect you to guess that, oh, they're the same, but they're actually not. The reason why these percent decreases hurt more is because you're always doing that percentage change on a bigger value. When you do the percent increase, you're doing the percent change on a smaller value. So you're always taking off more with the percent decrease than you're adding on with the percent increase. So how can you solve this? You can do the long math way, but what I like to do, and there are some of these relationships that are more well known. These general rules, though, these formulas are things that I've come up with to help remember. So instead of percents, you could think of these as fractions. So just in terms of terminology, I'll call these inner fractions and outer fractions. An inner fraction is something that makes something smaller, and an outer fraction is something that makes something bigger. So for example, if you have a percent decrease of 60%, you can write that as 3/5. To get back to the original, you actually need a percent increase of 150%, which is 3/2. So that formula here is my general rule up here, where if you have a percent decrease that you can write as n over n plus k, like 3/5 is the same thing as 3/3 plus 2, then to get back to the original, to balance it out, in other words, is just 3/2. And just like the example on the slide before, if you have a 10% decrease, say, remember we looked at this and the 10% increase didn't get you back there. You actually need something closer to an 11% increase, or more precisely 1/9. So if you look at the first corollary here, if you have a 1/10 or 10% decrease, you actually need a 1/9. So that works with common fractions like 1/3 decrease, you balance that with a 1/2% increase. That's something that's common on these exams where they'll tell you, oh, there's a 33.3% decrease, and then you actually need a 50% increase to get back there. The last kind of formula I have here for something that's easy to remember is if you have a percent decrease of something that's like 2/3, 3/4, where the denominator is one more than the numerator, then actually the percent increase is just the numerator. So for example, if something decreases by 75%, then that's 3/4, you need a percent increase of 300%. So that might seem kind of new and possibly confusing. I'm going to give a couple examples of more GRE GMAT-esque sort of questions where you show how to use them. So the first example is, let's say you have a large farm initially. You say a large farm initially owned 1,100 chickens in 2015, and it grew by 200% in 2024. Some of the chickens got sick in 2025, and now the population is back to the 2015 number of 1,100. What percentage of chickens did the farm lose in 2025? Again, you can do the full math solution, and I'll show that for you here. That's where you take the first step is do the 200% calculation. So 200% of 1,100 is 2,200. Fine. The new amount of 2024, you add that. So the 2,200 plus 1,100, 3,300. Then you need to do the percent decrease, which again, is 2,200 because you go back to that 1,100. And then do the percent decrease formula, and that gets you 66.7%. That's 2/3. That's several steps, and it's easy to lose track on doing percent calculations on your scratch paper, and you could make mistakes here. But what if you noticed that the 200% here, that 200% increase is one of the formulas that we mentioned, right? So call this a fraction of 2/1. So that's just balanced by the 2/2 plus 1, or 2/3. There you go, 66.7%. So for this one, if you work to use the formulas and you remember how that relationship works, you can actually get to this answer C without doing any sort of calculation. I'm going to do one more example on percent changes before we go into the arithmetic ones, just so you can see a different way that you can use this. And again, this is more of like an intuitive solution, more of an estimation. So sometimes using estimation is really helpful instead of doing exact calculations on these exams. So let's say you have a car called the Falcon, has a base sticker price of $32,500. A buyer, Steve, is interested in purchasing the Falcon with features that raise the price by 35%, but Steve is given a 25% discount on the purchase. So this is getting more along the lines of the type of question worded in a way that you'd see on the GRE or GMAT. Then it asks, how much does Steve pay for the Falcon? So look at the answer choices here. They're very ugly, and you wouldn't want to do these calculations by hand. On the GMAT, you don't have a calculator. On the GRE, you do have a calculator, but it'd actually be really tedious to try to pull up the calculator and type in all these numbers. It's not really recommended to do that. What you want to do is estimate. So when we talked about the 25% decrease there, that matched up with that's 1/4. That matches up with a 1/3% increase. So this isn't a 33% increase, right? It's a little bit more than that. So what we know is that the answer, when you have a 35% raise in price and a 25% discount, it should be a little bit higher than the original base sticker price, but not much higher. So if we look at the answer choices, answer choice A is lower. You could immediately cross that off. And then C and D are much higher. So B, 32,906 is really close to 32,500. That's what we're looking for. One other thing I'll point out with a question like this is look at E. This is what I'd call an oddball answer choice. So sometimes you want to triage answer choices on these exams. where if you see an answer choice that looks a lot different from the others, like this one is a nice, clean, neat number, that's probably not right. So if there's one answer out of 5 that look very different, very likely on these exams, that one isn't going to be accurate. Okay. So I'm going to stop there. We're going to go into the next section soon. Want to see if there's, oh, sorry, the presentation mode. I can't see the comments when I do this, but is this, does this look better? Okay. All right, I will pull this into presentation mode. If someone wants to stop me and ask a question, feel free to unmute and just call it to me because I can't see the comments while having this in presentation mode. Okay, so that whole first section was to kind of show you how using formulas can save you time and discuss the intuition of some of these math problems and how to triage answer choices. If you would like to use that percent increase formula, you'd probably have to practice a little bit and get used to some of the common things like 1.5 and 1/3 together and 1/10 and 1/11 together and so on. These are going to be, I think, a little bit easier to pick up and apply. Again, these will save you a lot of time and make things a lot more accurate on the exams. So I have 6 of these shortcuts here. One, you can call it the multiplying by 5. Sometimes we can call it doubling or halving because you could use this with other numbers besides 5. But for 5 in particular, instead multiply by 10 and divide by 2. We'll go through examples of all of these. There's a multiplying by 11, which is a pretty sleek trick where you kind of, if you multiply 11 by a 2-digit number, you add those 2 digits together and put the result in the middle, and it turns into a 3-digit number. We'll see how that looks too. For squaring numbers ending in 5, those will always end in 25. So you take the 5 out and look at the rest of the digits. Take that number, add 1 to it, and then multiply that itself by the 1 plus 1. So again, we'll look at examples of what this looks like. It's a very quick way to square any number ending in 5. The fourth one is a cool trick just because it shows you there's almost like a psychology around this math. So to find a percent of a number, sometimes it's easier if you just flip where the percentage sign is. So the numbers actually don't change in this, but your brain finds it easier to process. So we'll take a look at that as well. Then we'll look at multiplying numbers that are close to 100. This one is a little bit more tricky, kind of like how the percent increase and decreases might be a little tricky. This one might look a little new to you, but it's a fast way to multiply 2 numbers together. If they're, let's say, in the range of 90 to 110, so if you have numbers like 93 and 107, you can multiply those together pretty quickly. The last is squaring any number ending in 1. And this is actually a very fast formula. So here are the examples. We're going to go through these 6 one at a time. The first one is the doubling and halving. So let's say if you had a number like 48 times 5. That would take, maybe 20 seconds to do in your scratch paper. Same amount of time probably to pull up the calculator on the GRE. And there's always the problem when you do that of making a mistake, carrying a number wrong, and so on. But you could think of this as doing 24 times 10. So you just divide the first number in half, multiply the second number by 2 to get it to be 10. Multiplying a number by 10 is really easy. 24 times 10 is 240. Great. Now, other numbers besides 5, where you do the doubling and halving, are where you can get to something that looks really easy. So if you had 150 times 8, you might notice, oh, well, if I double 150, that's 300. It's probably easy to multiply something by 300 because it ends in a couple zeros. So you change 150 times 8 to 300 times 4. That's basically like doing 3 times 4, 1200. You just put the 2 zeros at the end. Again, really simple. And then this also works if you have things like decimals. So sometimes you'll see calculations that have decimals and sometimes a lot of zeros after the decimal, and it's really hard to do the bookkeeping to keep those decimals in place. But you might be able to do some doubling and halving to see, oh, I can rewrite this. So for example, if you had 12.5 times 20, you can double the 12.5 to get 25 and half the 20 to get 10. Again, you're back to that 10, really simple, 25 times 10 is 250. Then we have the multiplying by 11 trick. So this is something that I would recommend doing with two-digit numbers. On these exams, you're probably going to do it with a two-digit number. I have examples of a three-digit number here. It's a little more complicated and probably harder to remember. The two-digit one is really easy to remember. So basically, if whatever number you're multiplying by 11, you add those two digits together and put in the middle. Sorry, do you have a question?
No, your screen is not moving. I don't know if it's just me, but I'm still on the. Yeah, now it's moved. It wasn't changing.
Wasn't changing.
Yeah.
So do you see this now?
Now we can see the
Okay.
doubling having.
Yeah, I think there was maybe when I went to presentation mode, it wasn't moving. That's strange. Let's see here. Okay. So I think you guys probably didn't see these example problems here before. But for the doubling and halving, these are kind of straightforward, and I could I can share this with you guys later, so you have this. But yeah, that's a simple, straightforward concept. Multiplying by 11, like I said, it can be a slick trick for two-digit numbers like 42. So for this, all you do is you add the digits together. That's 6, and you put in the middle. So 42 times 11 is just 462. That's how I would probably keep it. Again, I have these other examples in case you're adventurous and want to practice them, but the logic works the same way. If you have a three-digit number like 452 times 11, you kind of have to leave 2 spaces in the middle, and then you add up the numbers on the left, 4 plus 5, and the numbers on the right, 5 plus 2, and then put those in the middle. So it's 4, and then 4 plus 5 is 9, 5 plus 2 is 7, and then the 2 at the end. So like 452 times 11 is 4972, whereas the 9 comes from replacing the 5 there with the 4 plus 5, and then the 7, the 5 plus 2 is 7. So again, that's definitely a trick you can use, but most likely you'd see it with 2 digits. And I put this third example in here. This is something I would probably not recommend unless you get really, really comfortable with these. But if it starts to be something where the numbers you add together are bigger than 9, you have to start carrying ones. That would be really hard to do in your head. So it's just good to be aware that could happen. If you have something like this, then maybe you do want to just write them down and keep it instead of trying to do it mentally. Okay. The next 2 examples I have here are squaring ending in 5 and flipping the percent. Can you guys see the deck now? The right slide. Great. Okay.
Yes.
So squaring ending in 5. This is one of the ones that you may have seen before, but it's again really simple. So the result will always end in 25. That's good. And then you basically remove that 5 out, and anything you have left, you take that number, add 1, and multiply those together. So 35 squared, you take that 3, do 3 times 4, it's 12, so it's 1225. Again, no calculations needed. That's something you could probably remember and figure out really easy. Even if you have much bigger numbers, it doesn't really get much harder. So if you have 305 squared, you can just do 30 times 31. And that's also pretty easy to do in your head because 30 times 30 is 900, an extra 30, 930. So 930, 25. Really quick to do. If you wrote that out, even typing that into a calculator again would be a lot longer. And then I put a 4-digit number in here just to show you sometimes you could even do this with 4-digit numbers. Less likely you'll see that sort of thing. But 1005 squared, you take the 100 apart. 100 times 101 is 101, 10,100, and then add the 25 at the end. Now flip the percentage. This is what I said. This is more of like almost like a mental trick to yourself than really a math trick. So look at the first example. If you were asked to do 18% of 50, that might be something that would cause you some pause, right? If someone said, oh, just tell me right away what's 18% of 50. What if someone told you what's 50% of 18? That's really easy. That's 9, right? 50% of 18 is just half of 18. So try to look at these numbers both ways, because sometimes they'll put the percent on the one that's just mentally harder to do and causes you to paralyze, be like, wait, I have to write this all out. And then the calculations are really hard and keeping track of decimals. But if you can flip them, sometimes they're a lot more obvious. Like 50% of 18 is just half of 18, 9. A couple other examples to show you where this could be powerful. So if you were asked to do 13% of 300, again, that's a hard calculation. But if someone asked you to do 300% of 13, well, 300% of 13 is just 3 times 13, 39. Or here's an example, again, with decimals, where I showed a previous example of the doubling and halving, where using decimals can make things really tricky in terms of arithmetic. This one I did in a couple steps just for myself, but still better than doing the long multiplication. So 800% of 0.25. Let's say if you flip that, 0.25% of 800. Okay, so that's getting closer, but still a little bit hard. So what you do is you move the decimal place to the right twice for that 0.25, move to the left twice for the 8, and now you're just looking at 25% of 8. 25% of 8, a quarter of 8, that's 2. That's something that's easy to do in my head. So I'll stop there with these two. I've got 2 more, but do those kind of make sense to people?
Hi, Jacob. Somebody had a question. I'd just like to ask it for them. Maybe they don't have a mic, but they said, can you explain the what you have left piece again? I think this is when you were talking about the squaring ending in 5, I believe.
Squaring ending in 5? Sure. So it's basically you remove if it ends in 5, you just separate that 5 out. So anything that's left. So for 35, you take 3 times 4, because the 3 is what's left. For 305 squared, you separate the 5, you're left with 30. So you do 30 times 31, and so on. So what's left is basically everything but the 5. You take the rest of the number, think of it as like a separate number, and then you add 1, multiply it together.
Thank you.
No problem. Okay. So we have 2 more of these arithmetic tricks. This one is called multiplying numbers that are close to 100. Again, this is one of the ones where I'd say if you're really more adventurous and want to practice, this would be good to practice. It does take a little bit more practice than some of the others. But if you have numbers like 97 times 96, right? Those are numbers close to 100. You can use these steps. So think of these as a difference from 100. So the first number is 3 less than 100. Second number is 4 less than 100. So 97 is 3 away from 100. 96 is 4 away from 100. And then you can do it either way, but kind of doing a cross result. So you can do 97 minus 4, or you can do 96 minus 3. It doesn't matter which one you do. Just finding the cross result there. So 97 minus 4 is 93. Then you multiply those numbers that we had, those differences from 100, 3 times 4, that's 12. So you do 93, 12, and there you go. So if you're multiplying 97 times 96, the answer is 9312, 93, 12. So I'll show a second example here to show numbers bigger than 100. So you have 104 times 107. Those differences from 100, you do -4 and -7. Again, you subtract either way, and you get 111. You multiply the -4 and -7 together to get 28. So you do 111, 28, and that's it. So that can be useful sometimes. And again, for the people who are dedicated to be real math nerds, I think that's more of an advanced one. But it probably is coming up a little bit less often. And then the last trick I have here, which probably comes up more often and something that is actually really easy to apply, is squaring numbers ending in 1. So this is nice because it's the formula is pretty straightforward to apply. And it's the type of question that is asked a lot on these exams. So let's say you had 41 squared. You write that as 40 plus 1 squared instead of just doing 41 squared. And this follows this binomial expansion formula. So 40 plus 1 squared, you write that as 40 squared plus 2 times 40 plus 1. And 40 squared is a lot easier to do in your head. That's 1600 plus 80 plus 1. And then the second example is if you had 51 squared, write that as 50 plus 1 squared. Again, you do 50 squared plus 2 times 50 plus 1. So 2500 plus 100 plus 1. So you see how this math is always really clean. It's always going to end in 1 there. And it's always going to be basically the number minus 1 times 2 times that number plus 1 at the end. Okay. So that's for like doing the mental math. Going to go into a couple other tricks you can use. So one is the difference of squares formula. So you can use the difference of squares formula to convert these like ugly calculations to use by using the difference of squares. So you basically replace ugly calculations with this formula and it can simplify. So this is a good way where you can look for patterns to rewrite numbers and look for things with these squares. You could also do it in the reverse. So I have some examples where you look at numbers multiplied together and you write it with the difference of square formula. Or you could have something that is a difference of squares, and this is a common thing that the test will give you. And to solve those patterns, you rewrite it with this formula. So this is very, very common on both the GRE and GMAT. So let's look at a few examples here. So you had 98 times 102. So you could write this as a difference of squares with the difference being 100. So 98 is 100 minus 2, and 102 is 100 plus 2. So you write 100 minus 2 times 100 plus 2. And with the difference of squares formula, it's equal to x squared minus y squared. So x squared, 100 squared, minus y squared, that's minus 2 squared. So you just have 100 squared minus 4. 100 squared is 10,000. 10,000 minus 4, that's your 9,996 there. So I'm going to stop for a second just to make sure that everyone is following and you're familiar with this difference of squares formula, first of all. Okay. This is a formula that you should definitely recognize. So like x squared minus y squared is equal to x minus y times x plus y. That's a very common formula on these exams. So another similar example, 51 times 49. Those are both around 50. So you have 50 plus 1 times 50 minus 1. And then that's 50 squared minus 1 squared. Very easy to do, 2,500 minus 1. So just 2,499. The last example is one of these patterns that you're likely to see on the exam, where they give you something that looks like 1,001 squared minus 99 squared. And that's something you definitely don't want to do. So in this case, you always want to rewrite it with the formula. Some of the other examples I gave before, like these arithmetic shortcuts, you could write things down in the long way and get to it. More likely that you will make some errors and it might take you a little more time, but you can do it. If you see something like this on the exam, 1,001 squared minus 999 squared, you're never going to want to do that by hand. That is a definite trap. And whenever you see that, think, okay, there must be some shortcut. There must be some pattern here that I need to recognize. And the pattern is this follows the difference of squares formula. So we write this as 1001 minus 99 times 1001 plus 99. That actually simplifies really nicely. 1001 minus 99 is just 2. 1001 plus 999 is 2000. So this ugly difference of squares thing is really just doing 2 times 2000, which is 4000, which is way easier than trying to write out 1001 squared, then writing out 999 squared, and then taking the difference of them. Good. Okay. All right, and then the last one is factoring quadratics. So sometimes you'll see quadratics on the exam where that's when you have the format of ax squared plus bx plus c. Usually a will be 1. On some of the harder questions, sometimes a will be bigger than 1, and you'll be asked to factor it. And factoring when a is bigger than 1 can be kind of tricky. It takes some guesswork to do it with the traditional solution, and I don't like doing it that way. So this is the trick that I use. It looks a little bit like bad math, but it always works. So if you have something like 6x squared plus 11x plus 24, you multiply. Sorry, if 6x squared plus 11x plus 4, you multiply the 6 times the 4, so that a times the c, you get 24. So rewrite that. And then you factor like normal. And normally when you factor, you just put an x here. We're going to put 6x in both spots instead of a 6x and a plain x. So again, that looks like it's going to give you, it won't give you that 6x squared that you're looking for. But the reason why we can do this is because 100% of the time, this will cancel out and simplify in some way or another. So I put the 6x here, even if it looks wrong, and then try to factor the old way. So to get the 11 in the middle and the 24 at the end, we need two numbers that add to 11 and two numbers that multiply together to get 24. So 3 plus 8 is 11. 3 times 8 is 24, so that works. But we're not done. The last step is you have to cancel out some sort of factor here to simplify those 6x's. And turns out we can cancel out by dividing by 3 with the first term and dividing by 2 with the second term. So you get 2x plus 1 times 3x plus 4. And there's the answer. So it's essentially doing the factoring like you normally would do if this was just 1, except you write whatever the a is, you keep that there, and then know that things are going to cross out. So instead of guessing like, should this be 6x and x or 2x and 3x and so on, there's multiple different ways you can do it. You see the traditional solution here. There's actually a lot of steps and factoring greatest common factor from each. You don't need to figure that out and do the guesswork. This always works. Okay. Yeah, so we actually went through that pretty quickly. There's a lot of math tricks in here. I wanted to leave it open here though, in case you had any open questions about using math tricks or other kind of math tips for these exams.
I got a question for you, Jacob. So since this is, of course, like it's a lot especially if you're just seeing this for the first time, how would you recommend trying to get more familiar with them? Would you just take a practice exam and try to apply it as much as you can, or would you try one specific thing like consistently until it's familiar? What would you do?
Yeah, that's a great question. And like I was saying before, some of these are really easy to understand, like flipping the percent. Some of them are a little bit harder. So definitely stick with the ones that you feel comfortable with. But also, I highly recommend whenever you do practice questions, always do it in a realistic sort of test format, right? So I would recommend sticking with the official guide questions for like the GRE or GMAT, and always timing yourself with them. So timing yourself, especially on quant or math sections, is really important, because if you try to solve problems and you give yourself as much time as you want, you can be teaching yourself the wrong thing, because these exams are made for you to solve a math problem in 1 minute or 90 seconds, right? They're always designed to have these shortcuts in them. And these are some of the shortcuts. So you can always solve something in a longer way. And if you're a math person, like when I went to college, I got my bachelor's in math, right? But if you're too stubborn about doing things the correct mathy way, you might solve a question in 3 minutes and get it right. But on the exam, that's actually going to really hurt you. So I suggest every time you practice these, um, put the calculator aside and time yourself, and you'll start to force yourself to use some of these math tricks to do things quicker and more accurate under timed conditions and without the calculator. And you'll start to notice ones that come up more often and less often. If I have 10 different tricks in here, right, and you walk away with, oh, 3 or 4 of them I end up using a lot when you do practice, great. You don't need to know all of them, right? Um, these are good math tricks to know. I realize that not everyone's going to be able to apply all of them on the exam, depending on how long you have to study and how comfortable you are with certain of them. But definitely a few of these, like the doubling and halving and the changing the percent, and some of the ones like that do come up quite a bit. The using the difference of squares formula to go back and forth and know how to identify when they're showing a difference of squares, maybe use the formula, or if there's things that are multiplied together, rewrite those as the difference of squares. So you'll start to see these patterns where the test makers will purposely use things like this, expecting you to recognize these sort of formulas or tricks a lot of the time. So yeah, I recommend just incorporating them into practice and doing realistic practice. No calculators, and time yourself, and use as best as you can the official guide materials rather than like third-party questions.
Great, thank you.
No problem. And yeah, I can send this out just as a reference for people if you want to like go back and see the example problems written in here. Yeah, so like for the GRE, it's the ETS for the official guide. So both for the GRE and the GMAT, they have like official questions, and there's also these like for the GRE, there's the Power Prep, the online practice test, which that's the best way I think to get an accurate score for what you're doing. In terms of doing the full tests, I wouldn't spend a lot of time doing those practice tests until you've studied enough. So you can create your own like mini sections of doing like 20 minutes worth of quant questions at a time, and pulling them from those, like let's say the ETS materials, that guide that they put out with the real GRE practice questions. And then once you're feeling comfortable enough to measure your score, then I would sit down and do the full like Power Prep exams. The reason why I wouldn't recommend doing too many of those is because they take a lot of time, and you're not learning that much. You're learning the timing and how the exam feels, but not so much in terms of solving the problems. So it's important to do those, and you probably want to do a couple of them throughout your studies to kind of track how you're going. But I would do a lot of practice questions and then understanding and reviewing the practice questions again. So what I like to tell people is keep a log of questions that, one, obviously if you get wrong, or if like you guessed, which is the same thing as getting wrong. But two, if you got it right, but it took you way too long and you know that there's a more efficient solution, also put that in your log, like keep a notebook or something. Yeah, so there's 2 free power preps for the GRE. Yeah, and I think you can pay for 2 more. And I really wouldn't recommend doing more than 4. So even 2 is probably enough. I'd probably do, if you're gonna do just 2, I'd do 1 like in the middle of your studies to see how you're doing, and then do 1 more towards the end. And if you want to, I think there's a 3rd or 4th one you could buy that aren't free, that you can do, if in case your study goes on longer and you're not happy with your score, you can use those as backups. Yeah. Okay. So thanks for joining. You can let me know if you have any other questions. We do have a few more minutes. But if you would like, you could also book a free intro call with me. I'm happy to talk about your potential study plans and what you need help with on these exams. I do both the quant and verbal sections. So this was just a little crash course in some of the quant stuff, but I tutor both sections as well. So thank you.